Hello, boys and girls, and welcome to my presentation on Lesson 6, Chapter 10 in Go Math. My name is Mrs. Roman. I'll be presenting to you today. I am a 6th grade bilingual teacher at East Middle School. So, how do we find the area of regular polygons? That's the topic for today. We have two objectives. Our content objective, which means what are you going to learn? At the end of this, you should be able to say, I can find the area of regular polygons. And then second objective, like your second goal is language. You have to focus on language. There's 4 parts of language: reading, writing, speaking, and listening. And I want you to be able to, at the end of all of this, I want you to be able to say, I can explain orally the process of finding the area of a regular polygon. Like, yes, I know the process, and I want you to be able to say all the steps to the process. So what is a regular polygon? A polygon is a flat figure that is made up of straight lines, and it is enclosed, means that it's not open, it's closed up. And yes, I know polygon, what that is, but what's a regular polygon? A regular polygon has all equal sides and angles. So all the sides on the polygon are the same, and all the measurements of all the angles are the same. And all the sides are straight lines, okay? And it's a closed shape. What does it mean that it's flat? It means it's a plane figure or two-dimensional, not 3D. You wouldn't be able to hold it in your hand. Straight lines. In geometry, which is what we're doing now, we're not in algebra anymore, are known as segments in geometry, okay? Straight lines are segments. And something that's enclosed means that there are absolutely no openings in this shape. So right here on the left side, you have all the shapes of the figures that are not enclosed. This is what a regular polygon is not. See, here's curved lines. This cannot be a regular polygon. This is open. It's not enclosed. This is curved. It's not a straight line. But let's talk about what is it. What is a regular polygon? Here's some examples. A triangle, a square, they have straight lines. They have the same size angles here. They're congruent, they're the same. This is a pentagon, right? All of these have straight lines. All the straight lines are the same size and all their angles are the same. And they all are enclosed. There's no openings, okay? What is area? Let me refresh your memory on what is area. So the amount of space inside a boundary of a flat object, such as triangle or circle. So how much space is inside a shape? The space. So everything that colored purple here is the area. Nothing outside of it, not the border. That would be perimeter. Don't get confused. Only what's inside. Okay. Now look at the shapes and think, well, all these shapes are regular polygons. How can I find the area of a regular polygon? What do I know from my previous lessons in Chapter 10? Do I know how to find the area of a square? Do I know how to find the area of a rectangle or triangle? Will any of that information help me? If you think and you pause this video and you just stare at this, you might be able to figure out. Because of time constraints, I'm just going to move forward. But I bet you could figure out if you pause this video. How can you find the area? What's all that space inside this shape? This is a hexagon. This one is an octagon, 8 sides. This has 6 sides. This has 5 sides. Well, here we go. The way you're going to do it is you're going to get your shape. This one so happens to be a pentagon. I know it's a pentagon because I have 1, 2, 3, 4, 5 straight lines. When you have straight lines, you count them, how many straight lines there are. In this case, there are 5. If I look it up on Google, shape with 5 sides is a pentagon. So this one's a pentagon. What you can do is you can draw lines to the center of your shape from the vertices where these 2 lines connect. These are called vertices. You go to the center. Go to the vertices, go to the center. Go to the vertices, go to the center. Vertices, center. Now I have 5 triangles make 1 pentagon. That's cool, right? So now what I'm going to do is I know how to find the area of 1 triangle. You've learned that already. So if you can find the area of this 1 triangle, that'll give you a clue, because if I know the area of this triangle and all these triangles are the same size, Then what I can do is I can get this area plus this area plus this one plus this one plus this one. I get the whole total, or this area times all 5 because there are 5. So here we go. Let's focus on finding the area of one triangle. One triangle. To find the area of one triangle, I do half the base times the height. So I'm going to plug in this information. The base, the bottom part of the triangle, B for bottom, B for base, okay? That's how I remember it. 20 centimeters is the base. So here we go. I put the 20 for the letter B. 14 is the height from the top, mounted top of the triangle down to the base, straight down is 14 centimeters. Here's 14. I'm going to replace the H with 14. So now what's half of 20? 10. And what is 10 times 14? Well, anytime you multiply something times 10, you just add a 0 at the back of that number. So we have a 10 times 14 is 140. So I know that the space inside this one triangle right here is 140 centimeters squared. Remember, you put a little 2 to show something squared, okay, when we're talking about area. Now, find the area of the regular polygon. Well, I know there's 5 triangles. So 5 times 140, because 140 is one triangle, 5 times 140 would be 700. Very easy. Cover that 0. 5 times 14. If you know 5 times 14, you do the calculation, you'll get 70, and then you add the 0 at the end. You can do it that way too. So my final answer is that the area of the pentagon shape piece is 700 centimeters squared. This whole thing is 700 centimeters squared. Let's go over 2 more examples together, and then you're going to try to do one on your own. Examples. Let's start with number 2. This is also a pentagon. Pentagon has 5 sides. Remember, draw this line from the vertices where these 2 lines connect, the sides connect, to the center of the shape. That's 1. From here to here, that's 2. From here to here, that's 3. Here to here, that's 4. And here to here, that's 5. So I should have 5 triangles here. Now I'm going to do what I did last time. I got to just focus on one triangle. One triangle is, we got to figure out the formula for having the area of one triangle. It's area equals half the base times height. So you write that down in your notes. Area equals 1/2 times 6 times 4. Where'd I get the 6 from? Well, my base is 6 and base comes first. Bottom number, the base, 6. Times 4. 4 is the height. So I replace the H with 4. What's half of 6? A 3. What's half of 6? 3. All right, so I did that. I usually put a little arrow right here to bring it down. And then multiply your answer times 4. 3 times 4 is 12. So the area of one triangle is 12 meters squared. Now that I know I have this area for one triangle, I have to ask myself, how many triangles are in this pentagon? We said 5, right? So go ahead, and what we're going to do is I'm going to multiply 5 times 12. Because I have 5 triangles times 12 for one area of 1 will give me the whole entire space. So 5 times 12 is 60. And the unit measurement that they used was meters. So I'm going to put meters squared because I'm talking about a 2-dimensional figure. I thought that it might be cool for you guys to do a screenshot of this if you want to mark it up with your phone. Or however you want to be able to count the sides, because on number 3 there's a lot of sides here, and for you to be able to count all of them while you're doing it with me, or you're doing it something on the screen, you can also take a picture and mark them up on your picture. So how many sides do we have here? What shape is this? Well, this is a decagon. Anytime you see deca in a word, it means out of 10. Decagon because it has 10 sides and 10 vertices. Okay, if you sit there and count them all, we have 10. So first I got to find the area of this one triangle. Area equals half the base times the height. So half times 8. 8 is my base. I'm replacing the B with the base, which is 8. Height, H is being replaced with 12 because 12 is the height. So what is half of 8? It's 4. What is half of 12? I'm so sorry. No. What is half of 8? Sorry, it's 4 times 12. Now 4 times 12 is 48. 48 meters squared. Now that I know that the area for one triangle is 48 meters squared, Now, what about all the triangles? There are 10 triangles that are supposed to be in here. So I have to do 48 times 10. 48 times 10. And that'll give me 480 millimeters squared. Now on your own. Independent practice. Find the area of the regular polygon. First, ask yourself, what shape is this? How many sides does it have? How many triangles are in this shape? What is the formula to find the area of a triangle? You should know that. What is the area of one triangle? It's the area of just this one triangle. How do I apply all the information that I've gathered to know the area of the entire polygon? Use all this information now to figure out the final answer. This should not be an N here, I'm sorry. The area of what kind of shape? The area of this shape is how many centimeters squared? You have to fill in the answers. You can write it down, pause this video, do your calculations, answer all these questions, and I'm going to move forward and tell you the answer. But you should be pausing the video now to calculate on your own, and then you can fast forward the video to see the final answer. Well, boys and girls, if you did your calculations right, your final answer should be that it was a hexagon, it had 6 sides, and it's an area of 168 centimeters squared. If you don't want to write squared, you can put a little 2 right up here. All right, guys, good luck with your assignment.